Alrighty, so in this video, I am going to do one example of each of the 4 operations with decimals. So these are in your notes. They are in right where they all are, which is the announcements or in the module 4 information. So we're going to do one of each so you can see the examples. So the key thing to notice when it has here is when do we line up the decimal first and when do we move the decimal after? Well, I will tell you, in addition and subtraction, that is when we line up the decimal first. So that was that line 'em up song that we did a couple of weeks ago. So let's do an example of addition. So we're going to do an addition example. So we can pick any numbers, it doesn't really matter. So I'm just going to pick 2.67 plus 0.3. Okay, so in this case, actually let's do 10.3. So in this case, the first step, it says for addition, line up your decimals. So this is how I set it up. I know I'm doing an addition problem, and my answer is also going to have a decimal lined up. Okay, doesn't matter which one goes first, so let's do 2.67. So 2 decimal 6 7. And then we have 10.3. So the 1 goes here, 10.3. The key here is to make sure that your numbers are sweetly lined up. Okay, you want your numbers and your decimals lined up. I think I showed you the trick with turning your paper on the side so you can use those lines. And then we're going to put in what I like to call ghost zeros just so it looks pretty to fill in those blanks because you can put zeros anywhere. So now we just add. So 7 plus 0 is 7. 6 plus 3 is 9. 2 plus 0 is 10. And 0 plus 1 is 1. We don't need to move the decimal because we lined them up in the beginning, and that would be your final answer. Pretty simple. So let's do a subtraction example. Okay, so let's do 12 minus 3.83. Right, so we are doing a subtraction example. So it says for subtraction, line up your decimals. This needs to happen first. So let's line them up. Now, when you have subtraction, it does matter which one goes first. So we want to do 12. Now, the decimal, the whole number doesn't have a decimal, but it is assumed to be right behind it. So 12 goes there. And then we have 3.83. So I lined up my decimal. So I'm going to go ahead and put these ghost zeros in just because they look nice and I like them. Makes everything kind of align pretty. All right. So I can't do 0 minus 3. I have to borrow. I can't borrow from here. I can borrow from here. So this turns into a 1. Then we have 9, and all the way over is where I needed to go, which was 10. So now we have 10 minus 3, which is 7. 9 minus 8, which is 1. I can't do 1 minus 3, so I end up having to borrow again from here. So this turns into a 0, and this will turn into an 11. And then we have 11 minus 3, which is 8. 0 minus 0 is 0, and you can put a 0 here if you want to, but this would be your final answer. All right, so that's addition and subtraction. Let's go ahead and switch gears. Now we're going to do multiplication. We're going to do a multiplication example here. So in multiplication, it says count the digits after the decimal and bump the decimal in your answer. So in this case, we do not need to align our decimals ahead of time. We're going to move it later. So let's just pick a number. Let's do 8.2 times, I don't know, 2.03. Okay, so in this case, we do not need to align our decimals. Okay, all we need to do is multiply like a multi-digit number and we'll move the decimal after in our answer. This is our answer, so that's when you're going to move it. So when it comes to multiplication, doesn't matter what order, I'm going to put the longer number on top because I can. It doesn't matter as long as the longer number's on top. And actually, let me make this look prettier. I want to align my actual numbers here. So 2.03 and 8.2. All right, so it says count the digits after the decimal. So how many numbers do I have behind my decimal? Well, I have one, oh, be helping me with drawing. I have 1, 2, 3. So at the end, I'm going to end up moving my decimal 3 places because I have 3 numbers behind the decimals. All right, so this is multi-digit. So kind of when you're actually doing the multiplication, ignore the decimal. We're going to move it later. So we need to multiply this 2 to everything. So 2 times 3 is 6. 2 times 0 is 0. And 2 times 2 is 4. Now we need to do a placeholder because we're going to go to the second number, which is 8, and we're going to multiply this 8 to everything. 8 times 3 is 24, so carry the 2. 8 times 0 is 0, plus 2 more is 2. And then 8 times 2 is 16. We don't have to carry the 1 because there's nowhere for it to go. So then our next step is we add them up. Again, this is a normal procedure for a multi-digit number. 6 plus 0 is 6. 0 plus 4 is 4. 4 plus 2 is 6. And then 6 and 1. Now this is that key here. It told us that we need to move our decimal 3 places. It says bump the decimal in your answer. So we need to move it 1, 2, 3 spaces. So our final answer would be 16.646. Not too bad. All right, our very last one is division. So in division, we're going to go ahead and it says bump in from the front and line up your decimals. So let me show you what I mean by that. So let's go ahead and pick a number. So let's do, I don't know, 8.4 divided by 0.68. All right, so we need decimals. So what that means is we're going to go ahead and set up our division, and we have 8.4 and then 0.68. So it says bump in from the front. So what that means is we cannot have a division or a decimal out here. We actually need to slide that decimal over to the right for all the way to the right. So we need to slide it 1, 2, and that's how it would get to the right. So we slid it twice. If we do that, we have to slide this 8.4 decimal 1, 2 to the right as well. Okay, then you line up your decimal. Then this guy comes straight up. And you're probably wondering, well, what goes there? It's a 0. You can just put a 0 anywhere there's blanks. So I'll review that one more time. So because this number that we are dividing by is not a whole number, we have to make it one. So we move our decimal all the way to the right. And if we move that one, we have to move this one as well. So we'll move this one to the right as well. Now we're pretty much dealing with 68 into 840. So I'm going to just clear this up just a smidge so we don't have all this here. So now we're dealing with 68. How many times does it go into 840? So this is that normal long division. Okay, so 68 cannot go into 8, but 68 can go into 84 one time. So that's minus 68. So we're going to have to borrow. 14 minus 8 is 6, and we have 16. We got to bring down our 0. 68 into 160. I believe it goes in twice. Let's see, 68 times 2. 2 times 8 is 16. 2 times 6 is 12. Yep, that's 136. Subtract. We're going to have to borrow. 10 minus 6 is 4. 5 minus 3 is 2. Now, in order to go to the next step, we actually, behind the decimal, you can add as many zeros as you want. So we're going to add a 0 behind the decimal and bring that guy down. Now we have to figure out how many times 68 goes into 240, and I believe it's 4 times, but let's just triple check. 8 times 4 is 32. 6 times 4 is 24, 25, 26, 27. Nope, that's too much. So it is 3. So we have 68 times 3. 3 times 8 is 24. 3 times 6 is 18, plus 2 more is 20. Okay, so then it goes in 3 times, which is 204. We're going to have to borrow 3. So again, we'll add another 0, and then you can figure out how many times 68 goes into 360. This number up here can keep going forever, but the procedure that I want you to master, you're probably not going to get a very long run on decimal, is the fact that we had to move that decimal first. So we move it so that this number here has it all the way to the right, and then we move this one the same amount. Okay, if this procedure is confusing, then we might have to review. I would go ahead and Google some videos on long division because that didn't change anything. The only thing that was new this year was moving the decimal. I hope this video was helpful. Feel free to review as much as you want and to rewatch it.